Hi friends, welcome back. So today we will see another case study. This is on network intrusion detection, right? We will use kNN here, another famous algorithm of supervised learning. So basically this is the context of the data set, that the data set to be audited was provided with this consisting of the military network environment, right? So this is containing all the detail of the data set, what type of data we have, the columns and everything is here. The main objective is to make a analysis in intrusion detection, right? So let's start with the kNN. So first we are importing the libraries, that is numpy, pandas, seaborn, matplotlib, right, for all the visualization and numerical and data analysis thing. Then we are importing our data. So this is the CSV file that I will also provide in the description, right? The link you can access from there. Now we are importing by just read CSV from network intrusion. We are converting first it into the data frame, right? So here you can see that, and getting the head. So this is what our data set looks like. Now we are getting the shape. So show the shape, you can see the number of rows multiplied by number of columns, right? And then we have data set dot d types. All the data types of all the attributes is here. So here you can see the prototype, right? Object is there, integer is there, float is there, everything is there, right? Next thing is the transpose. So data set dot describe dot transpose. So if you do transpose, so you will get the description of all the values, right? So here you can see that all the description is here along with count, mean, standard deviation, min, mod, and with transpose of these, all right, all the column with respect to all the columns. Next thing is checking all the null values. So again we will do is null dot sum. So it will return the sum of the null values that we have. Then we are doing data set class dot values count normalize equals to true. So here you can see normal, anomaly, and name class. This is d type, float 64, right? Now we are plotting a bar plot. So here you can see that pd dot value count data set class plot kind equals to bar. So it will plot the bar for normal and anomaly. Okay, next thing what we will do is we are going to use label encoder to convert categorical variable to one hot encoding, right? Which is nothing but the dummy variable. So we are first importing label encoder, and we are telling that okay, in that just take label encoder data set class, that will be le.fit transform, right? Data set class data set equals to protocol type le.fit transform data set protocol type, data set service le.fit transform data set service, and data set flag equals to le.fit transform data set flag. So here we will take data set dot column. So you can see that all the column value is there, right, in the data set that we have. Next thing, we are doing a standardization of the data, again importing pre-processing and standard scaler. So here you can see that after importing that, what we will do is x standard, and inside in that x standard variable we are containing a standard scaler dot fit transform, that is data set, and x standard dot columns equals to data set dot columns. Now split the data set into training and test data set. So importing numpy as np from sklearn dot model selection, import train test split. Now transform data into features and target. So x equals to this one, y equals to this one, split into train and test. So here you can see that train test split. So train test split is xy, test size equals to 0.2. that means test size is our 20% and 80% is our training side. Again random state is also high for seeding the values. And if we print the train shape and y, train shape of x and train shape of y, you can see that the x train and y train, right? Similarly for x test and y test. Now build the model and train and test on training and test sets respectively using scikit-learn. Print the accuracy of the model, right, with the difference values of k equals to 359. So now loading libraries. So these will be our libraries: kNeighbors classifier, accuracy score, recall score, right? And then instantiate learning model, that is k equals to 3, kNN, kNeighbor classifiers, n equals to neighbors equals to 3, right? Fitting the model, that is kNN dot fit x train y train, predict the response, y prediction will be kNN dot predict x test, evaluating accuracy, so print accuracy score will be y test and y prediction, instantiate learning model, that will be k equals to 5, and kNN will be k neighbors classifier, which will be n neighbors, that will be 5. So right, we are getting the k values as 5. Now fitting the model, again kNN dot fit x train y train, predicting the response, again kNN dot predict for x test, right? Evaluate accuracy, so calling that accuracy score function, passing y test and y prediction, and then instantiate learning model, that this time the k value we are giving as 9, and again fitting the model kNN dot fit x train y train, and predicting the response again. So here you can see that we have defined k 3 times. One is 3, another is 5, and another is 9. So you can see that for 3 we got this accuracy, for 5 we got this accuracy, and for 9 we got this accuracy. So the best accuracy we got when the k value is 3, I mean that is in this case, right? So this is what we should always try with different k value. Now running the kNN with number of neighbors to be 1 3 5 up to 19, and find the optimal number of neighbors from the above list using the misclassification error. So creating odd list of k for kNN. Now my list equals to list of range 1 to 20, subsetting just the odd ones. So neighbors list equals to filter, we are doing lambda x, right? With x we are checking the even values in the my list, right? So to filter out odd values. Okay, now empty list, that will hold accuracy score. So this is the empty list we have defined, and perform accuracy matrix for values from 1 to 19. So we have defined a simpler function for k in neighbors, kNN equals to k neighbor classifier, n neighbors equals to kNN dot fit x train y train, predict the response, y prediction will be kNN dot predict x test, evaluate accuracy score equals to accuracy score y test y prediction, and AC underscore scores dot append will be scores. Now changing to misclassification error, MSC equals to 1 minus x for x in AC score, determining best k. So optimal k will be neighbors, MSC dot index min of MSC, printing the optimal number of neighbor is percent is what, so it will be our optimal k. So the optimal number of neighbors is 3 basically. Now plotting misclassification error versus k, where with k value on x-axis and using matplotlib, right? Now importing matplotlib pyplot for plotting the or visualizing the graph, and plotting misclassification error versus k. So how I will do that? First I'm plotting neighbors with MSC, right? X label, y label. X label is containing number of neighbors k, and y label is misclassification error, right? So here you can see that this is what the misclassification error, as the number of k is increased. Now next thing is we are also checking with k equals to 3 as the final model for prediction we have seen earlier, right? Which have given the best accuracy amongst all, and fitting the model k fit y prediction, again the same thing. This is the accuracy score and the recall score, right? So we can say that the final model has good accuracy when we have the k as 3, right? So this way we can check with different values of k, right? And in last video I have told you how can we take k, right? Or we can make a right decision to take k. So friend, yeah, this was all about this video. I hope you liked it. If yes, please do like and share, comment if you have any query. If not like, just dislike the video, right? So that I can get the valuable feedback from you to improve something in further, because the feedback that I'll get from you will definitely help me or our team to improve or work further in the content, right? So thanks a lot. Have a good day. Thanks.